here with one more flipped classroom video. 3 tips before we start. You can always speed up or slow down this playback speed if that helps you get through the video. Second, you can pause the video at any time and catch up on your notes. Last, you can turn on the captions and watch my words go by on the bottom of your screen. All right, let's take a look at a few more details for the unit circle. So what I've done here is I've marked off my unit circle with my 4 sort of cardinal points. These are the easy to get points on the unit circle. And remember, our radius is 1. So the distance from the center to this point on the circle is 1. And that's why this point is the point 1, 0. Now I've marked the quadrants, first quadrant, second, third, and fourth. So we can take a look at that too, because there's some interesting relationships. First off, I want to talk about angle measurement. This direction, counterclockwise, is positive. So if I say you have a 30-degree angle, you're starting here and you're going positive 30 that way. Okay? If you go this direction, your angle is negative. So if I say negative 180, you're going to start here and you're going 180 degrees around to that one. So that's just a reference point. When you're measuring angles on the unit circle, positive is counterclockwise. So it could be a little confusing because we're going anti-clockwise, the different direction than a clock goes. You might think clock goes positive, but on the unit circle, the clock is actually rotating in a negative direction. Okay, second thing, you remember what we did in the last video about the sign of cosine, sine, and tangent as you go around the unit circle. We have an acronym. It's all silly turtles crawl. And what that means is that tells you which things are positive as you go around. So all means all 3 things. Sine, cosine, and tangent are positive in the quadrant 1. So this is the all. Now silly starts with S. So sine is positive here. Now that makes sense because sine is the up and down value on the unit circle. So sine is the only thing that's going to be positive there. Now in quadrant 3, we've got turtles. That's tangent. Because in quadrant 3, both sine and cosine are negative, but you'll remember tangent is sine divided by cosine, negative divided by negative is positive. So tangent is positive here. And then finally, crawl stands for cosine C. So here, cosine is positive. Okay, so that helps you remember the sign of the trigonometric function based on the angle. So angle 0 to 90, all 3 functions are positive. From 90 to 180, only sine is positive. From 180 to 270, tangent is positive. And then finally from 270 back to 360, cosine is positive. So let's do that with radians. From 0 to pi over 2, all are positive. From pi over 2 to pi, sine is positive. From pi to 3 pi over 2, tangent is positive. And from 3 pi over 2 to 2 pi, cosine is positive. Let's tease out some interesting relationships with trigonometry and the unit circle. So let's start with sine theta. We know that sine theta is y. That is this y value coming up off of the x-axis. So sine theta is y. Now I want to ask you, what do you think sine of 180 minus theta is? So pause the video, think about that, come up with your answer, and come back. Okay, so check this out. If this is theta, then 180, which is all the way over here, minus theta is going to be right there. So that's going to also be the same y. It's coming up off of here. The same angle is coming off of there. So that's going to be the same y. So sine of 180 minus theta is also y. So now I'm going to ask you, what is sine of negative theta? Pause the video and write that down. Okay, let's see how you did. Now, if positive theta is up this way, negative theta is going to be down like that. So we're going to have a ray. Let's solve that one. So this is also theta. So now that's going to be down that distance. So sine of negative theta is negative y. Pretty interesting. Now try this one. What is negative sine of theta? What's that going to be? Pause the video and write that answer down. Okay, that one is also negative y. We've just taken sine of theta is y, so if the negative is on the outside, you take the sine first and then you negativize it, so that's going to also be negative. One last one. How about sine of 180 plus theta? Pause the video and figure that one out. All right, so sine of 180 plus theta is, we're going to go 180, that puts us here. Theta more puts us here. Now that's the same amount down from the x-axis as we were up with our other theta. So this is just another one that's minus y. Now you can do a whole lot of these types of things with the unit circle, with the sine function. So we haven't done every single one, and so some of that's going to be left for you to tease out in the exercises or what? Maybe on a test. Now let's do the same thing with cosine theta, and I'm going to ask you to do a bunch of those in just a sec. But first off, cosine theta is x. So cosine theta is this value there. So we're moving along the x-axis. So when you're thinking about cosine theta, you're always thinking about where we are on the x-axis. All right, so try these four. Pause the video and do all of those. Do your thinking, move around on the unit circle, and figure out what these values are going to be. Let's see how you did. So cosine of 180 minus theta is, we've come all the way around 180 and then we're going back theta. And so now we are here on the x-axis. So we're at minus x for cosine 180 minus theta. Now you remember with sine, we were still at y. We didn't change the sign of it because we're still up above the x-axis. But with cosine, we've come all the way around and we're on the negative side of the x-axis. So that's why we're at negative x for cosine 180 minus theta. Now cosine negative theta means we've come down this way. We've rotated in a negative direction, but we're still to the right of the origin. So x is still positive, so that's why that's positive. Negative cosine theta is just cosine theta, but negativized, so we have a negative x there. And then cosine 180 plus theta, we've come all the way around 180, we've gone theta more degrees. Now we're still to the left of the origin, so our x value along the x-axis is negative. All right, I want to show you another identity that's actually a little bit more powerful than the last two, and one that we can use to do a lot of cool stuff. So what I've done is I've drawn my unit circle here. I've noted to you that the radius is 1. That's important. And then let me make another little deal here. There's a right angle. So I've got a nice right triangle here. So now you can make an equation based on this right triangle that we can manipulate, and we can show sine and cosine in that identity. So go ahead and pause the video. Think about the Pythagorean theorem and write an equation for this little triangle right in here with theta there. All right, pretty simple, right? The hypotenuse is 1, so x squared plus y squared is going to equal 1 squared, okay? Now, we know some things. In this unit, we've been talking about what x and y are. So pause the video and make another step in our little equation here. Okay, so I remembered that x is cosine theta, and y is sine theta. And I also remember that 1 squared is just 1. So I brought that down. I switched sides on these, and I also changed the order because this is how we typically write this identity. So sine squared theta. So basically we've just taken sine theta and squared it. So the squared is here, but what that really means is this, is sine theta squared. That's what that really means, but we read it sine squared theta plus cosine squared theta equals 1. Now that's a trigonometric identity that allows us to do some pretty fun stuff on the unit circle. All right, let's do a few problems. I repeated our identities from the last few boards. We have our sine theta equals sine 180 minus theta, cosine theta equals cosine minus theta, and finally our last one, sine squared theta plus cosine squared theta equals 1. So you're going to need to use these to do the problems I'm going to work you through here. Okay, so here's one. Find an obtuse angle that has the same sine as 70 degrees. Now I'm not drawing a unit circle, but we are bouncing around on the unit circle here. So the same sine as 70 degrees. So that leads us right to this one. Pause the video and do that math. So all I did is I just used this equation and I substituted theta in for that. And so I have sine of 180 minus 70, which is the sine of 110. So the angle that has the same sine as 70 degrees is 110 degrees. Now the cool thing is you can just pull out your calculator and pop in those numbers to confirm that indeed those are correct. And the calculator will verify that. So now I want you to pause the video and do the same question, but now I've given you your angle in radians. So that makes it a little bit different, but you can do that. So pause the video and work that math. All right, so the trick I had to remember here is if I'm working in radians, then I need to remember how many radians is 180 degrees, because I'm going to use this same identity here. So that's pi radians. Remember, 360 is 2 pi radians, so going halfway around or 180 degrees is just pi radians. So I'm just doing pi radians minus pi over 4. So this is 4 pi over 4 minus 1 pi over 4 gives me 3 pi over 4. So that equivalent angle is 3 pi over 4 radians. Okay, 2 more, this time dealing with cosine. So find another positive angle that has the same cosine as 50 degrees. Now, from our unit circle, we know that 50 degrees is like this up here, and there's our cosine. It's our x value. Now, it's asking for a positive angle. Now, you could easily go, oh, yeah, of course, it's just negative 50 degrees, because we're still going to be to the right of the origin, so that will also be positive x. But it's asking for a positive angle. So go ahead, pause the video, and do that math, and come back. Okay, so we're working in degrees here. So the equivalent angle to minus 50 is going to be 360 going all the way around and then backing off by 50 or subtracting 50. So I just did cosine 360 minus 50, which is cosine 310. So cosine of 310 will give you the same value as cosine of 50. And you can check that on your calculator. So that's another positive angle that has the same cosine as 50. Now let's do the same trick, but now you're using 2 pi over 3 radians. All right, so I'm going to do the same thing I did here. I'm going to subtract 360, but now I'm working in radians, so I need to remember what that is. And so all the 360 degrees is 2 pi. That's how many radians it takes to go all the way around a circle. So I've got 2 pi minus 2 pi over 3. That ends up giving me 4 pi over 3. So that is the same angle in radians as 2 pi over 3 that would give us the same value if you pop that into your calculator with the cosine function. All right, let me give you one last one, and I'll give you a hint. It deals with this identity. So go ahead, here's the prompt. Without finding theta, okay? So you're not going to use this to find theta. I mean, if I'm telling you what sine theta is, you could do the inverse function of 3/5 and find out what theta is. But this is saying don't do that. So this kind of problem might show up on a non-calculator portion of an assessment. So without finding theta, find cosine theta when sine theta is 3/5 and theta is acute. We'll talk about that in a minute, but first let's just do the math on that. So I'm going to ask you now to pause the video and use this function or this identity to answer this question. All right, so I did the plug-in step. Sine theta is 3/5. So according to this, sine theta squared plus cosine squared theta is 1. So I just plugged it in. If sine theta is 3/5, then sine squared theta is 3/5 squared. Cosine squared theta, we don't know that yet, and we know that it's 1. So go ahead and see if you can take this to the conclusion. All right, let's see how you did. So all I did is I squared my little fraction here, and I got 9 over 25 plus cosine squared theta equals 1. I subtracted my 9 over 25 from both sides, so now I have cosine squared theta equals 16 over 25. Now, cosine squared theta, I can just take the square root of that to get cosine theta. So cosine theta equals plus or minus 4 over 5. These are both perfect squares. It worked out real nice. So my solution is that without finding theta, we don't know what theta is. We could use a calculator, we could do that, but we don't need it to answer this question. Without finding theta, we found cosine theta when sine theta is 3/5. Cosine theta could be plus or minus 4/5. All right, so check this out. We had to drop the minus. So minus cosine theta doesn't fit within that condition. And here's why. So here's my answer. I just wrote that. Check this out. So here's cosine theta, acute angle right there. Okay, so that gave us the positive 4/5 value for cosine, because remember that's the x value. Now there is this other angle where if you come up theta from from the x-axis going backwards, we also have that same theta, and that gives us the value of minus 4/5. And whatever theta is, that will work. However, this theta, as measured from our starting point, like here, that's 90 plus theta. That's not an acute angle. So that's why we have to scratch the negative 4/5. Now that you've watched the video, take a moment to jot down any questions so you can bring them to our next class. Remember that you can always watch the video again to deepen your understanding. If you enjoyed the video, please click like or subscribe.